Hey everyone. Wow, this is bright. So many people. So how many of you have struggled with debugging your servers in production? Just a quick show of hands. That's pretty good. It's a pretty large number of people. When I debug my apps in production, this is a representation of what that looks like. I stare at AWS and complain. I hope by the end of this talk, it'll look more something like this. Looking and knowing immediately what is wrong because your observability is great. But first, let me quickly introduce myself. I'm Luca. I'm a software engineer at Deno. This is some of my colleagues. How many of you know what Deno is? Let's do another show of hands. Wow, that's, yeah, nearly everyone. For those of you who don't know what Deno is a server-side runtime, like Node. It can run your Node.js apps out of the box. But it comes with a bunch of interesting things built in, like a formatter and a linter, and it runs TypeScript out of the box, and it uses ESM by default, and a whole bunch of other cool things. I'm also a delegate at TC39, so you heard Ujwal talk about TC39 this morning. He's there. Dan's there too, who you're going to be hearing a talk from in an hour. And I work on Winter's TC as well, which is a standards body dedicated to, or sorry, not a standards body, standards group inside of ECMA dedicated to making server-side runtimes more compatible. So making your code from Node work well in Deno or in Bun or the other way around. And I contribute to a bunch of web specs as well. So how do you have a good debugging experience? Well, you start out with having all the data. Because if you don't have any data, there's nothing that you can debug in production. And the data that you really want is like, what happened, who triggered it, how long did it take to be able to analyze for performance problems, when did it start, to be able to pinpoint when something went wrong, and what request is it part of. I'll talk more about the last one in a second. Most applications already create logs. How many of you like use console log? Okay, anybody that didn't raise your hand, you're lying. There's unfortunately a bit of a problem with logs in the case of servers, which is that if you have a bunch of logs for requests that are coming in at the same time, so parallel requests, which is very common in servers, you can often not associate which requests belong to what logs. And this then ends up with situations like this. So I have a server here that logged something out. 2 HTTP incoming requests, it made 2 database queries, and then there was an error that some column null is undefined, or some column name is null. Does book 1 or book 2 have a null name field? Who can tell me? Nobody, exactly, because you don't have the data. This is one problem with logs. Logs can be really useful, but they can also really be very tricky to work with if there's not enough data attached to them. So let's spice up our logs a little bit. This is something any of you can do in your applications today. What if we associate a request ID with every log, and actually with every request? So when you get an incoming request, we assign it an ID. For simplicity's sake, let's say 1 and 2. And then every time you log something out, you print out that ID with it. And now it's really easy to tell it was book 1, because the request ID for that error is the same one as for the log line for the first GET request. So this can be a bit cumbersome, though. I mean, you could write code like this. I'm sorry, this is a bit small, but you could like generate a random request ID and then pass it in through your entire application. In every single function, you take the current request ID and print it out in your logs. Who of you thinks that this is a maintainable way to do this? Nobody. Good. Such smart people here in the audience. This is going to get really repetitive, so let's not do this. Let's do something else. And I'm going to show you a demo real quick and then explain what's going on. So I have a little application here that I've written for Deno and TypeScript, but it's actually using Express. You can see I'm using Express here, actually using the new Express 5. And this is all the application does. So creating an app here, I have a handler that handles API calls to API book with an ID, and then it makes a database call, and we're just serving that on port 8000. And I'm not actually connecting to a database. I just have like a little fake database in this function that takes 300 milliseconds. So what I can do now is start this up with Deno. And it's now serving on localhost 8000. And let me curl this. you all see this? Yeah. And that works. Cool. So I don't see any logs. Oh, right. I forgot to add the logs. Let's do the logs. So let's add some logs over here. And I'm not going to associate them with any request ID. I'm just going to print out the same logs that you saw in my slides. So yeah, Copilot, good. Why write code yourself if you can have someone else do it? Console log, and here we're going to print out database get book from database, and let's print out the book ID as well. And let's restart the server and curl this, and you can see it didn't print out any request IDs, but I have a trick up my sleeve, which is that actually this is exporting logs to my telemetry system, to Grafana right now. So if I switch over here to Chrome and open up Grafana, and hopefully you can all see this, and query my logs, I will see the logs here that I just created. So here's my HTTP call, and let me make another couple HTTP calls, and maybe also an error, and query that. And you can see all the logs here. And you still don't see any trace IDs or any request IDs, but if I click on one of these logs, there is this ID associated with that log. And if I filter down by this trace ID, you can now see that I'm only seeing logs for that specific request. So Deno has somehow automatically added an ID to each of my logs that associates it with the request that it came from. And this is particularly useful for the error, right? I have an error here, don't know where it came from. Let me filter it by the trace ID. And I can see it was book 2. So yay. So what's happening here? This is not magic. I know it looks like magic. It's not. It's called async context propagation. And what's really going on here is that the system is essentially has some state that it passes down every time a promise is created. Every time you call await or you call a new function, there's this state that we implicitly propagate with your call. And that way, you can, at some point, sort of create this request ID, and Deno does that automatically, without you having to do anything. And then it propagates it into all of the functions that are ultimately going to be called from that request. And actually, under the hood, this uses a TC39 proposal that's not quite released yet, but we already have internal access in Deno, called async context. So if you want to check this out, this is the thing that backs this. We'll be able to use it in the browser at some point. This is actually also what makes React Server components work in XJS. Completely different reason it uses that, but okay. So what else can we use this for? We can use this to track who triggered something. So we know which request triggered it, but if I have an error, I may want to answer questions like, why did a specific operation get started? Like who, maybe I have multiple call sites that are both doing a database query. I want to know which one of the two call sites called my database query. And that's really useful because let's say one of the call sites passes incorrect arguments all the time. I would like to figure out which one that is. We can use the same context propagation system for this by making it figure out what the parent operation is. So an operation here is like anything that you want to track, so maybe like an HTTP request or a database call or like deleting something from disk or really anything that's interesting to you. And you want to track what the parent is. This gets us traces. Traces are what? Traces are this, are the ability for you to see who triggered what, when, and how long did it take. So looking at this graph, there's a lot of information in this graph. This is one request. You can see that it was a GET request to the books endpoint. It then did an authorization check, which under the hood made a call to, I don't know, Redis, for example. That took 10.2 milliseconds, didn't fail. It then did another call to Redis. It did 2 database queries. It did a set to Redis. You can tell immediately, like, maybe if there's a performance problem, like, what are you going to start working on? You're not going to work on Redis, and you're not going to work on the authorization handler. You're going to work on making your database query faster, right? This is something that you can get with traces. And you can also see, maybe you could have parallelized these 2 queries. They're currently running back to back. Maybe they could have been running in parallel. So traces are made of spans. That's the technical term in OpenTelemetry. A span is really just an operation that records like what the operation is, so the name, maybe some attributes like what the query was, what parameters, how long it took, when it started, who triggered it, the parent span. and then what trace ID is part of. And which trace ID it's part of is that thing we were looking at before with the context propagation. So you can know which request triggered what. If you're more visual, this is what that looks like. I have two spans here, the HTTP request and the database call. They both have some attributes. The HTTP request, for example, tracks what path the user hit, and it tracks how long it took. It has the trace ID. It has a span ID. A span ID is within the trace, the order of operations of the operations. And then the database call looks very similar, has some different attributes on it, and it has a parent span ID. And the parent span ID says this operation was started by this other operation. So here the parent span ID is 1, the HTTP request is span 1, so we know that the database call was triggered by the HTTP request. So as I said before, this helps you answer why questions about specific requests. Why did the request take long? Why did it error? What query did it fail in? Why is the wrong thing happening? You don't even know what, you know something is up, but you don't know what. This can really help you figure that out. So let's do a demo for that as well. I don't have to do anything. Let's start by just opening Grafana. And instead of looking at logs, let's look at traces. And let me send a request. And, query that. And here is our latest request. And, is that the latest one? No, that's not the latest one. There we go. So this is the latest request. And you can see there's currently only a single span here, this root span from the HTTP server. And it has some attributes on it, it responded with the 200 status code. This is the path that I hit. This is how long it took. But we probably also want to instrument your database query. So how do we do that? Well, it's really easy. You just write some code that does this. And I have a little helper utility called withSpan that I can just wrap any function with, give it a name. Let's call this getBookFromDatabase. Sorry, this is sort of scrolling off the screen here. And parentheses. And this is going to pass in the span that it creates, and I can use that to record some attributes onto the span. So maybe I want to record the book ID. So book ID is the book ID. And now if I restart my server and curl this again, and I'm also going to create an error, and then give it a couple seconds. There it is. We now have two spans. So we can see that there was the incoming HTTP span, the one that was automatically created by Deno. And then we have the one that I just created with my book1 attribute on it. And actually, let's also look at an error span. This is what it looks like in the error case. So here, I can very quickly, just by looking at this, tell that the reason this request failed is because the database request failed. So I could look in this more, and I can see, the message is book is missing author. Cool. I now know book 2 is missing an author, immediately know where to fix the problem. So that's traces and spans. Who of you here uses microservices or runs like more than one service in production? Okay, like maybe 25%. So you're all going to find this really cool. Traces don't just have to stay within one process, they can span processes. So they can go from one service into a different service. So a quick reminder, spans need to know their parent, right? But what if each of the spans is in a different service? Well, what we have to do for the other span to know its parent is to send along the information of what its parent is. And we can do that, for example, through HTTP headers. This is called propagation. There's a spec from the W3C called trace context that specifies this trace parent header that essentially just contains like the current trace ID and span ID. And when you send a request from one service to a different service, if you include this header and the other service understands it, it will just continue the trace, the same one that the first service started. I'll demo that in a second. So the DIY approach to implement this looks something like this. You get the current span, and you then get the span context from it. You build this header, put in the trace ID, put in the span ID, add the trace parent header, call fetch. Again, this is really annoying. Who wants to write code like this all the time? You don't, so don't do this. And you know, this just, again, works out of the box. So let's create a new file here that I'm going to call, I don't know, main TS, I guess. And we're just going to do a fetch call from this one service to the other service, just getting the first book, like this. Okay, and we're going to log out the book. And I still have the server running, the original one. I'm going to start up a second server. And this requested the book. That worked. I see the database query and the HTTP log. And if I head back to Grafana, you can see that I have a new trace. And if you look carefully here, you can see that the service is not the book API anymore, but it's the fetcher, because that's where the trace started. And if I click on this, and I have 3 spans, 1 green and 2 purple. This is the outbound fetch span from my first process, and it automatically propagated into the second Deno process, where I can continue. So you could imagine that if you have a lot of microservices, this could be really deep, right? You could even instrument your database and like have your database query planner output spans that you can see in here. Cool. So we can now debug things if they go wrong. If we know like what request failed, we can go look at it and figure out why. But this still leaves us with a problem. How do you even know that your website is down or that there's some other problem that needs to be investigated? So the first approach is you wait until your users tell you. How many of you operate on that principle? Good. Brave man over there. Yeah, this is probably not the best idea, though. You want to be ahead of your users, right? You want to know when something is wrong before your users tell you. And the way to do this is through metrics. Metrics are like aggregate information about the health of your service that you can set alerts up for. So for example, here I have a metric chart that just tracks the number of requests per second with a given status code. I could set up an alert here that says if more than 5% of my requests end in a 500, I want to like be wrung out of bed at 3 in the morning. Probably you don't want to have this be set at 5%. Probably you want to have this set at like 0.5%. But you know, yeah, you create metrics in your application, and then you can alert on them. And Deno also does this out of the box. So actually, I don't even have to do anything else here. I can just, again, open Grafana and look at metrics this time. We're going to look at duration seconds count. I know this is a bit confusing of a name for what I'm going to show you. This is the number of HTTP requests processed in any given minute over the past, well, I don't know, whenever this graph started. And actually, I'm going to close this to have some more space. And, oh, sorry. I'm not used to working on such a zoomed-in Grafana. OK, so here's what we're going to do. We're going to send like a quintillion requests to my API here and see if we can see them in the metrics. The metrics only update once a minute, which is fine. But that means we may have to wait for a second. Oh, there we go. Cool. So you can see there was a bunch of requests. And actually, if I want to see this by status code, I can do that. I now have the number of requests by status code. So over the last however many minutes, I got 3,000 requests with a 200 status code and 1 request with a 500. And every time I make another request, that would result in a 500. That would obviously show up here, too. OK, so that's metrics. Those are the 3 pillars of OpenTelemetry. So I've showed you this in the context of Deno, but this is applicable not just to Deno, but it's also applicable to Node, to any other programming language you may want to learn or already know. Java, Go, Rust, they all have this. Logs. What happened? When did it happen? And maybe you know which request it's part of if you have the trace ID stuff. Traces. What happened? Who triggered it? When did it happen? How long did it take? And which request it's a part of? Traces are like the thing that you use to debug things if you already know there's a problem and you want to figure out what the problem is. And metrics, if you want to get woken up at 3 in the morning because your app is down. So yeah, that's in Deno 2.2. Telemetry is built right in. So for those of you who haven't tried, I would urge you to try. I'll show you in a second how. You can run any existing app, any existing Node app. In Deno, we have Node compatibility. Or you can run a new app with some framework for Deno, or yeah, whatever you want. As you saw, there's like not really much setup. Out of the box, you'll get the log correlation, so the console logs with the trace ID. You'll get traces for incoming HTTP requests and outgoing HTTP requests. You're going to get metrics for request count and request latency. You're going to get this automatic propagation across services. And there's a lot more stuff coming soon. Like, we just shipped this in 2.2, which was like, I don't know, a month ago. Yeah, and if you need more, you can really easily add your own log spans and metrics to your application. You just import at OpenTelemetry/API from NPM and create your own metrics. Count them, whatever you want. So if you want to try it out, this is a slide you want to take a picture of. Install Deno. I suggest you just start by setting up Grafana locally. It's really easy. There's instructions in our docs. And then you run Deno run on your entry point, go to Grafana, and you'll have logs. But if you're already using an existing observability stack like Datadog or Honeycomb, New Relic, Google Cloud Monitoring, AWS, anybody that supports Sentry, anybody that supports OTLP, you can ingest metrics, spans, and traces from Deno into. So yeah, that's my talk. Thank you all.
Luca Casonato, that was awesome. Thank you.